All right, let's talk about hypothesis testing. Actually, we'll continue our discussion from lecture 24. Here we have the null hypothesis when it's a general setting where we assume or hypothesize that a parameter is equal to a certain value. Let's say mu equals zero point 0.3. The alternative hypothesis is that the null hypothesis is not true. The parameter is not equal to zero point 0.3. The alternative hypothesis will depend on your research question. You can, instead of this unequal sign, you can pick greater than or less than sign. We'll talk about that more later. But when we assume that the parameter takes a certain value and we calculate a value from our sample, we want to check if this calculated value from our sample is away from this expected value, So one way to check is to first check the gap and then divide by standard deviation to standardize it, to scale it down for better comparison. From using this formula, we get the z-score. And the z-score tells us how far is our calculated value away from the expected value. So how far is this calculated value away from the value that we hypothesize? In a way, it's giving us the idea of how many standard deviations away is our calculated value from the expected value. Let's see an example. In this example, Humira is a medication that is used to treat rheumatoid arthritis, or RA. In the clinical trials, 7 out of 705 subjects diagnosed with RA were administered 40 mgs of Humira every other week, and 66 of them reported nausea as a side effect. Now, the interesting thing is, people who didn't receive Humira but received a placebo, they also reported nausea as a side effect. But the proportion of people who reported nausea as a side effect from the placebo group was 0.08, or 8% of people in the placebo group mentioned that they had nausea. Now we want to see if Humira is causing more people to have nausea compared to placebo. For this, we hypothesize that our expected value is 0.08, that is the expected proportion. This p is our parameter, and the alternative hypothesis is p is greater than 0.08. That means people who use Humira, they are more likely, more of them will experience nausea as opposed to the placebo group. First, we check the three conditions that we discussed in the class. First, the data set is from a randomized experiment, and this condition has to be, this number has to be greater than or equal to 10, and the sample is less than 5% of the population size. That means our sample is not overwhelmingly representing the population. And when we do the test statistics, or z-score, this is just the standard deviation for proportion. We have seen this formula before for calculating the standard deviation for any proportion. This is just representing the previous broad outline here, calculated value from our sample minus the value over the standard deviation. Now this P0 is what we saw in the placebo group, our hypothesized expected value, that is 0.08. The calculated value, calculated proportion from our sample is P hat, this one, which is 66 out of 705 people, equals to 0.094. So 0.094 is the value we received from our sample, and 0.08 is the value we received from the placebo group, or we hypothesize that this is the expected value of the parameter p. So when I'm talking expected value, that means the mean or expected value. So let's plot this in a normal distribution where we expect this value to be the mean. So 0.08 is in the middle for the actual variables normal distribution, and the value we receive from the sample p hat is 0.09, which is little away from this mean. To check how many standard deviation away is p hat from p0, we calculate the z-score. First calculate the gap and then divide by the standard deviation to get 1.37. So this value p hat corresponds to this z-score 1.37, which is somewhere here. Notice that the converted z-score has a mean 0. So this p0 value, the mean or expected value, corresponds to this 0. Now that we know that p hat is 1.37 standard deviation away from the mean, what do we do with this number? Notice that the 95% confidence interval, or a level of confidence equals to 0.05, gives us this z-score. That means the probability of this area of getting a number in this area is 0.05, the area under this curve, this part of the curve, right to the red line. And this z, corresponding z value here, is 1.645, which is bigger than 1.37. That means this p hat is 1.37 standard deviation away from the 0. But if we want to be 95% confident that this p hat is sufficiently away from p0, then this value, z naught, should have been somewhere here, somewhere right to this red line. Other than that, we cannot be 95% confident. So what if we change the level of alpha, level of confidence? If we set alpha equals 0.1 or 0.10, that means we want to be 90% confident. Then we get the corresponding z-score equals to 1.282, which is very close to our previous z naught value, but it's left to the z naught value. That means if we have a value equals to 1.37, that means the p hat is 1.37 standard deviation away from p0, then, and we set the level of confidence equals 0.1, that is, we want to be 90% confident, then we can reject the null hypothesis. But if we set the level of confidence equal to 95%, then we fail to reject the null hypothesis. When this z naught is bigger than this value, z 0.1 equals to 1.282. When it's bigger than this value, that means at the 90% confidence level, p hat is sufficiently away from p0. But at the 95% confidence level, p hat is not sufficiently away from p0. So we can be more than 90% confident, but less than 95% confidence. And that results in this situation where we can reject the null hypothesis at 90% confidence level, but we cannot reject the null hypothesis at 95% confidence level. So what is the confidence level where we can actually reject the null? What is the lowest level of confidence? What is the lowest level of confidence where we can actually reject the null? Notice that the area right to this black line, this will give you the lowest level of confidence where you can reject the null. Because if we get a value in here, then we can reject the null. But if we get a value left to this black line, we fail to reject the null. So what is the value of this area right to this black line? Our corresponding z-score is 1.37. So from this table, we can get 1.37 is the area left to this point. 1.37 is 0.9147. That means the area left to this black line is 0.9147. If we subtract this number from 1, we get the area right to this point, right to this black line. On the other hand, if we want to calculate in Excel, then we can use this formula, norm.s, as in standard normal dot dist as in distribution, and we put 1.37 and true because it's cumulative, so we get 0.91465, which is exactly equal to the probability that we received from our z table. And when we subtract this number from 1, we get 0.085. That means the area right to this black line is 0.085. In other words, 0.085 is the lowest level of significance where we can reject the null hypothesis. So let's write 0.085 in this z-score. So that means this area is 0.085 and this z-score is 1.37. That means with 0.085 level of confidence or 91.5% level of confidence, we can reject the null. If this goes any bigger, 0.085, then we fail to reject the null. That is the p-value of our analysis. So the p-value, that the probability of z bigger than z naught, which we calculated, is z bigger than 1.37 is 0.0853. So this is the p-value. On the other hand, the area right to this black line is the p-value. So in the classical method, we just compare the z-score that we calculated with a critical z-value. Let's say alpha equals 0.05, alpha equals 0.1, and we find if this z is bigger than this. If this z naught calculated z is bigger than critical z, we reject the null. If it's smaller than critical z, we fail to reject the null. But here we cannot get rid of subjectivity, because in our case, alpha equals 0.1 made us reject the null, and alpha equals 0.05 made us fail to reject the null. So it's subjective which alpha you choose, 0.05 or 0.1. But here we can directly report the p-value, which is less subjective. We say that this is the lowest level of significance where the null hypothesis can be rejected. So that's how these two methods, classical method and p-value method, are different. So in conclusion, we say at alpha equals 0.05, there is not sufficient evidence at alpha equals 0.05 level of significance to conclude that proportion of subjects taking Humira who experienced nausea is greater than 0.08.